Now, this is the team that we need to watch. You guys were the champions, right, in 2016?
Yeah, we were the champions in 2016.
Yeah. I've been watching your video. I got my eye on you, Now, I have, joining me is Matt. He's actually part of the team. So, Matt, tell me a little bit about what you do. Are you, you're a PhD student or what are you?
I'm a master's student in electrical engineering at the University of Florida. I'm the team leader, and I also run the electrical team.
Okay, great. So, were you involved with the team in 2016?
I was. I've been with the team since we started in the fall of 2015.
And how did you elevate to the team lead role?
Well, I've been in our lab quite a while, about 5.5 years now. And so when the last team leader stepped down so he could focus on his PhD and graduate at the end of 2016, I was the natural choice to be the team lead.
Okay, great. So tell me what's happening right now with the University of Florida.
So right
boat
now,
here in water.
Right now we're at the start gates. Between each start gate is an underwater beacon, and our goal is to find the gate with the beacon that's turned on. So we go to 2 different points on the left and right of the start gate, and we listen for the beacon. And we're able to get the bearing to the beacon, and then we find the intersection of those points, and that tells us which gate to go through.
So right now we're already in autonomous mode. It's kind of just going through or determining which one has the beacon, and the beacon will inform the vessel which gate to go through.
Correct. So it's currently listening at the second point for the beacon. Notice that it's kind of drifting in the wind. That's because we can't listen too well with our thrusters on.
Oh,
so now
okay.
It has decided where the beacon is, and it's going to line up and go there. It looks like it's decided the beacon was in the middle gate, and now it's approaching scan the code to look at the pattern.
Okay, so now from our vantage point, the scan the code, it looks like it's green, red, green.
Yes, it does look like that. Hopefully NaviGator thinks so too.
Okay. So what's going on with the boat? How is it determining that?
So we use our LiDAR, which is a depth perception sensor, to detect where the scan the code is. It has a kind of a distinct shape with its base and then a column in the middle, and we use that we kind of look for that shape in our LiDAR information. Now what it's doing is it has found scan the code. It's standing off so you can see it with the camera that's on the starboard side.
Okay, and so this is not it hasn't.
Excuse me. It looks like we've going somewhere else. But
so have you completed the scan the code exercise?
I'm not sure. We may have done it quickly.
I haven't heard the applause yet, so I'm kind of wondering, like,
yes.
Are they so? Based on what we're looking at, do you think that it's sort of moving on to the next exercise?
It would appear so. Yes.
Okay. Now, as a team member, do you know what the sequence of exercises you're undertaking?
Yeah. So the general sequence we're undertaking is kind of a clockwise rotation throughout the course, starting with the start gate, then scan the code. Then I believe we're supposed to go to the obstacle course next, then circling the totems, ending with the detect, deliver, and the underwater ring challenge.
All right, okay. I hope you make it to the detect and deliver, because I'm all excited about that, and I want to see the projectile go through the square. But okay, so right now you said you was going to go to the obstacle course, right? But it looks like it's sort of.
It looks like NaviGator got a little confused and needs to abort, come back.
Okay, so I heard that. I heard the abort. So that means that it's gone in manual mode, and it'll come back to the beginning and start again.
Well, while it transits back, I want to mention some people have really helped us out. We're really thankful to our departments, our EC department and our MAE department, as well as our industry.
Okay, what did you say? MAE?
Sorry, mechanical and aerospace engineering.
Okay.
And electrical and
feel
computer
free to
engineering.
call out to all the departments and don't just do the acronym, because nobody knows what the acronyms are.
And our former team lead, Andy Gray, he's helped us out a lot. And our industry partner is a company called Silphase. It's a startup from our former student focusing on sensors for autonomous robots. And then our lab, of course, is the Machine Intelligence Lab, or MIL. And some of our faculty advisors come from another lab called CIMAR, the Center for Intelligent Machines and Robotics at the University of Florida.
And then, that department, I mean, how long have they been around?
Mill?
Simar?
Simar's been around quite a while. They participate in all the DARPA Grand Challenges, but our lab, Mill, we've been around for over 20 years. We participated in every single Robo Sub competition, many of the Robo Boat competitions. This is our second RobotX competition, and we have a number of championships to our name.
Now tell me, what is it about the Florida and where you were at that has a lot of this activity going on? I mean, is there a big presence with in terms of the Navy or what is it that's driving a lot of this activity?
Yeah, so a lot of our activity is driven by our lab, Machine Intelligence Lab. It's been around for a very long time, over 30 years, and it's always been a place for people to come and kind of do the research they want to do with robots and work in an environment where everyone feels the same. So our lab is right now largely undergrad, and everyone in our lab is a volunteer. No one's paid to be in our lab, and they just really enjoy building robots and going to competitions like this.
So this machine intelligence lab, is it all kinds of robots? Is it terrestrial? Is it like unmanned aerial? Is it underwater? I mean, what specialty would you consider the machine intelligence lab?
Over the years, this Mill specialty has transitioned from stationary robots to ground vehicles, to ground and air vehicles. Our current focus is on water and underwater robotics.
Oh, okay.
So all marine robots.
Yeah. So tell me more. Did you get to thank everybody?
I did. I thanked everyone on my list. I should probably mention that our electrical and computer engineering department is run by Dr. Hahn, and our mechanical engineering, Dr. Harris, and our mechanical and aerospace engineering department is run by Dr. Hahn. And our big sponsors are Texas Instruments, Harris, Lockheed, Blue Origin, and Northrop Grumman.
Wow, that's some pretty big names.
Yes.
So those companies that you just mentioned, are they all located in Florida? Do they have a presence?
They're not. They're all global companies actually, but they do have groups in Florida with the exclusion of TI. The TI recruits a lot from our school and really believes in our lab.
And then so those companies, in terms of sponsorship, in what way do they help sponsor?
The sponsors I mentioned sponsor us fiscally.
Okay.
Silphase helps us with our sensors. It looks like we've started the entrance gate again. We're repeating the same pattern we did before, listening at 2 different points.
Okay, so now it's back in autonomous mode. It came back and basically restarted, right?
Yes, it did. We had to abort our first 2 runs. Oh, we're aborting this run as well.
Okay, so now this is a little concerning, right? So it didn't even try to get through the entry gate. What do you think happened to decide an abort?
It looked like they had some information early on that made them realize this wasn't going to be a terribly successful run. It looks like we're looking for a quick turnaround to go back to autonomous. Eavesdropping on what my team's saying. But ultimately, I know as much as you do right now.
Okay, which is not a lot, but I mean, like, they're right next to us.
It looks like we went autonomous again.
Okay. Now we got one.
I want to point out that our boat, we have 4 thrusters, 2 on the bow and 2 on the stern, and our thrusters aren't aligned with to front and back. They're actually angled at about 30 degrees. And the reason for that is it allows us to move in any direction we want and maintain a lot of control and maneuverability, which is a great help for a course like this where you need to maneuver around in between buoys and towers and obstacles like that.
Well, tell me more about some of the other systems that are on this vessel.
Sure. So outside of our thruster system, we actually have a pneumatic air system on board, and the pneumatic system powers our racquetball launcher, which we hope to use for detect deliver. It's an auto reloading system that uses 100 psi air to propel a racquetball through the squares on the detect deliver challenge. All of our electronics are housed in a car top carrier on top, and that's an effective and cost-effective way to protect your electronics while maintaining easy access to them. You just open the lid, and there's everything you need.
So that car top, that's the one that's silver that's sitting on top of the vessel, right?
Yes, we've covered it in reflective tape to help keep it cool.
Oh, I see. Okay, great. So now it's what? It's still in manual mode.
Correct. It looks like they're lining up for a new run. Now they're station keeping. we can tell it's station keeping because we've heard they haven't started the run yet, and the light is green, and it's not moving anywhere. Our station keeping code is very good. It's absolute station keeping. So we say stay here on planet Earth, and it will stay there.
So when you say station setting, right? Is that what you said?
It's keeping, station keeping.
Station keeping. What is it that's actually happening with the, sort of like the navigation, the propellers,
Yeah, sure. So we have our primary position sensor on NaviGator for absolute positioning is something called an INS, or inertial navigation system. It combines 4 different sensors: a GPS, something called an accelerometer, a magnetometer, and a gyroscope, and fuses all that data through some math called a common filter to establish the idea of where you are on Earth and which direction you are facing. That the product we use to do that is designed by our Silphase, run by a former student in our lab. And then, based on that information, when it detects that we have shifted away from where we want to be, our controller plots the thrust trajectories we need to get back to where we are, given our current rotation and where we and if it's to the left or the right or forward of us, where we need to go to.
Okay, so it's in autonomous mode. It's doing sort of talking to the beacons. I mean, determining which gate to go through.
Yes, we're doing this again. Hopefully, we'll be progressing from this point to the other challenges on the course. Once again, like we listen at one location, we move to a second location and listen there. But the idea behind this is when you listen, we have an array of 4 hydrophones, and what this does is just like the human ear, we have 2 ears on our head, and that allows you to tell if a sound is coming from the left of you, to the right of you, or behind you.
Okay,
looks
great.
like we went through the.
Whoop.
Not sure what's happening here. So just like you have 2 ears on your head, we have 4 ears on NaviGator.
Okay.
That allow us to
Listen to the beacons, right?
that tell you not only if it's to the left or the right of NaviGator, but how deep it is.
Oh,
and with
okay.
this information, we can say from where we are currently, it is to the right. And then when we move to a second location farther away, we say, oh, it's to the left. And we know it's which gate is in between.
Okay,
it looks like what happened here is we figured out that the buoy was the beacon was in between the red tower buoy and the white tower buoy, but then we thought it was too narrow for us to go through, so we went around.
Now, is that a acceptable performance, or do you have to go through?
It looks like we are letting it happen for the moment. We want to get the points for going through there.
Well, in order for you to go through it, you have to go through the red and the white.
Correct.
Right?
It looks like we have aborted and gone back to RC mode.
Okay. So
yeah, recovering our vehicle.
Now, can you have followed that path and then maybe backed up through the red and white?
Not for points.
Okay.
If we decide it's too narrow, we can't go through in any configuration, forward or back.
Now, when it determined that it was too narrow, I mean, you guys have done the qualifying rounds, right? So you've already gone through this. It's not like this is the first time. So what was it that changed this time to make it feel like it was too narrow?
So they reconfigured so for the first couple of days of competition, there were qualifying rounds, and they had courses laid out for that. Then they reconfigured the courses for the semifinals, and finally they reconfigured the courses for finals.
Oh, I see.
For finals, they try to make things harder on you.
Okay.
As they should.
Okay.
And so appears that they've tightened the tower buoys together.
Okay, so we don't expect a complaint letter from University of Florida to the judges, right?
No, we do not.
Okay. Okay, so now it's in autonomous mode. It's gonna continue the sort of initial sequence, right? Which is to
Correct.
listen to the beacons.
Yeah, we just got a word that we are autonomous and we'll be attempting this challenge again. So we're also told that the correct gate is the middle buoy, or the in between the white and white buoy in the center. So fingers crossed we'll go through that one. It looks like we're going now. So again, we'll listen at one point, listen at another point, and then go through.
Okay, so we know that the gate is 2, but the vessel has to now determine that on
Correct.
its own.
Yes, and the reason we're told that is that while we're running autonomously, our software team is not allowed to touch their computers or
Right.
remote control.
Right.
So we can be given information and not be expected to influence the robot
Got it.
behavior. When we go through the start gate, we're going to stop at scan the code and try to recognize the light pattern, which appears to be red, green, or red, blue, red. Once based off that information, after we go through the obstacle course, we'll go to the circle totems, and we should be circle the red totem, the blue totem, and then the red totem again.
Oh, okay. Now, I'm excited to see that because, the other previous teams went to the totem and were unable to complete that. So if you guys complete that, you'll be the first one today to do that.
We'd be happy with that.
Yeah.
We've done it a number of times during the semifinals runs the last couple of days. So
Okay, so
we're
from
confident in our ability.
so some of the teams have told me like which they have considered to be like the more difficult tasks to complete. Which does the University of Florida deem the most difficult?
To us, the difficult tasks are the scan the code challenge and detect deliver challenge. We're pretty happy with our ability to do the obstacle course and circle totems. So we rank them that way.
Oh, so you would say scan the code was one of the more difficult?
For our team, yes.
Oh.
Yes.
Now, how much of the the system has already been in place from 2016? Could you reuse that code or reuse the system? If you have to start from scratch? I mean, wasn't there some lessons already learned from the previous competition?
Yes. So we received our boat in the November of 2015.
Mm-hmm.
We were in the water a week later, and we got ready for the 2016 competition.
Mm-hmm.
Our strategy for getting ready in that short period of time, about 13 months, was to get something working and then go back later and improve it. So we had to get thrusters, electronics enclosures, sensors, write the controller and mission planning software, and then also complete the tasks. Of course, when we finished 2016, we didn't throw our boat away.
Mm-hmm.
So we started with a platform that had all the sensors and actuators and batteries and things that we needed, and then we were able to improve off of there. So from 2016 to 2018, our team strategy was to, based off the areas of improvement we noticed that in the 2016 competition, improve for the 2018 competition. So we did have a bit of a leg up in that we weren't starting from scratch again.
Now, recognizing that scan the code was a challenge, was there work being done in the period between 2016 and 2018 to improve or build your confidence for scan the code?
Yes, that's a challenge we worked on a little bit. Not enough.
No,
We're
not-
realizing we do work consistently. We work fall and spring semesters, excluding the summers, from the time competition ended to now.
Okay. Now, from what you just saw, did it complete the scan the code?
I'm not sure. It certainly drove by it.
Okay,
It
so
looks
we-
like right now we're going through the obstacle course.
Oh yeah. Okay, so we don't know. It's
Yeah.
moving on. It's moving on to the
Well,
obstacle course.
For the obstacle course, it's going to attempt to do a lawnmower pattern.
Okay.
So it'll cross the obstacle course and then turn around and come back. It should do that 3 times if everything runs correctly, and that will reward us with a fair number of points. The lawnmower pattern is considered the most difficult pattern to achieve.
Oh.
I want to talk about, I mentioned about we test it quite frequently. Back home, we have our university has a lake. And
Uh-huh.
we're able to test on the lake, so we go out there every other weekend, every weekend or so, and we take over a section of the lake for all day.
Okay.
We build replicas of every single course element, and our mechanical electrical teams deploy them while the software team writes the software or tests the software for NaviGator. It's a whole day affair. We make lunch and stuff like that. So it's what's interesting about these big robots compared to RoboBoat and RoboSub, if you've seen those, is how much logistics is involved in just testing the robot or even getting it to Hawaii.
Oh yeah. In fact, I was looking at just the team videos and all the work that you folks have done, at your home base, and imagining having to take that all apart and bringing it to Hawaii. I mean, that's incredible. So, how did you guys end up shipping this? Was it by air? And what's the challenge to disassemble it and bring it over here?
So the boat itself came here by air. We shipped a lot of tools. It came in a big crate. We ship a lot of tools and spare parts and things, and those come in Pelican cases also by air. When the boat returns, because we're not so concerned with how fast it gets back, it'll come by sea.
Oh, okay. So you do a surface delivery going back.
Correct. Yeah, sea and land.
Probably have to go through the Panama Canal. I mean,
Yes.
Is that the route?
Yes, goes through the Panama Canal. We went through the Panama Canal in 2016, and now in 2018, I'm sure we'll go back through it.
Well, maybe you'll get it in sometime in what, 2019?
Yes, we're supposed to get it in the end of the first week of 2019.
Oh, okay.
Which is
Well,
good
yeah,
because before that, our university is closed.
Okay.
So no one will be there to get it.
Now, in terms of, just curious, in terms of time of year, is this a good time of year or a bad time of year to do this exercise? I mean, given the fact that a lot of people are having finals and, they've got semesters ending. I mean, what did you guys have to do to actually deal with the coursework?
Yeah, I want to reiterate that our team is mostly undergrad. Of the 11 people that we brought, which are the ones that we were able to bring, 9 of them are undergrad and 2 are master's students. And of course, they have lots of finals, and so the competition falls during our finals week.
Right.
So the students individually can coordinate with their professors to either take exams early or to take them in Hawaii. Many of the students had to take exams in Hawaii. In fact, one student had to take 4 exams here, which is rough for him.
That doesn't make for a very good, Hawaii experience, taking finals in Hawaii.
No, it does not. It looks like NaviGator is transiting through the obstacle course. We went across, and now we come back, and hopefully we'll go across again.
So the programming is it predetermined how many times it goes back and forth in terms of the lawnmower run?
It is. We pre-code what tasks we're going to do and in what order, and then we also pre-code what you do during each task.
Okay.
We have a quite a nifty GUI mission planner, which is a GUI is just a screen where you can use your mouse and stuff to drag things around. So you drag the task into the task list, and you can reorder it and whatnot, and then you press go, and it goes and runs everything.
Okay, so now it's just kind of turning around to do maybe another run through the obstacle course?
Yes, it looks like it's starting that third run through the obstacle course. It takes a minute to plan its route because of the obstacles that are in the way. But luckily it sees them with the LiDAR. So if you notice, there's a lot of black buoys on the course.
Right.
And the way we see them is not with our camera, it's with our LiDAR. So a LiDAR is a depth perception sensor, so it sees this flat surface, and then it sees deformities in that surface, and we know that those deformities are obstacles that we can't go through, and we divide the world into squares, approximately a meter by a meter, and if we sense any deformities in that square, we mark that whole square as something we can't go through, and that's kind of like if you had a graph paper and you just colored in certain boxes and then try to draw a line through it, like a maze. And then we have a piece of software called a path planner that, given that maze, plans the best route to get from where you are to where you want to go.
So that LiDAR system, I mean, what does that include? I mean, and is that an expensive piece of equipment? I mean, what is it composed of?
LiDARs used to be an expensive piece of equipment, but they've gone down quite a bit recently in price in the last couple of years, especially with the rise of autonomous cars and just robotics in general.
Right.
It has 16 lasers that spin around in a 360-degree circle and measures the return of those lasers, much like a sonar would work, but a sonar uses sound while a LiDAR uses light. So
now the 16 lasers that you're talking about, I mean, can you sort of tell me where on the vessel it is?
Yeah, the LiDAR is a small puck. The top and bottom are silver, while the middle is black. It's located on the front of the vehicle, so it has the best view of the course from the vehicle's perspective. The way it tells the 3D depth is based on how much time the laser light leaves the sensor, hits something, and bounces back. And based on how long that took, you know how far away the thing is. And based on the strength of the return, you know how reflective the surface is. So the buoys they're black, so black absorbs a lot of light, while the ocean is water, and that has a different light absorption rate.
Do you know what frequency that laser is? Is it infrared or is it what?
It's certainly not visible. it's safe for human eyes. I don't know more beyond that.
Okay. So now it seems to have gone. I would have guessed that it would have gone to attempt to get toward that other side of the obstacle course, right? Which is
Yes.
from one end to the other end. But
So with the lawnmower pattern, you just have to go back and forth.
Right.
And normally we would transit. We would start on one side, go through, move a little bit, come back,
Right.
move a little bit,
Right.
go back again.
Right.
But it looks like maybe it decided it couldn't fit on the right-hand side, so it decided to keep going through the left-hand side.
Oh, okay,
Now
okay.
we should be transiting to the circle totem challenge.
okay, so it's already kind of finished the obstacle run. It's done its requirement, I guess, in terms of transiting back and forth. Now it's going to head over to the next exercise.
I believe so. We'll see what happens.
Okay, we'll see. I'm counting on it because I want to see you guys complete the totem exercise.
Thank you. While it transits and gets to the next, decides what to do, decide what it wants to do, and get to the next challenge, I do want to give a shout out to our judges and our staff here. They've really done a very good job instituting a culture of safety from the top on down that they've really driven into us. And for an institution, that's the best way to enforce safety rules is to really enforce them from the top on down. And I don't think we've had any safety incidents so far, and everyone knows that safety is the primary concern. There are plenty of safety checks before we go in the water, when we're on the water, as well as every team is required to have a very robust kill system, and its functionality is strictly enforced. So,
And that's a common message and theme across all the judges, right?
yes, they really got everyone on board with the safety with the safety culture, which is for the best. You want to be safe when doing anything, much less autonomous robotics on the open ocean.
Well, even sitting in this booth, I don't want this monitor to fall down.
Yeah, that would be pretty bad. It's just kind of hanging there.
Okay, so now it's at the totem, right?
Yes. So
And now it's gonna, based on the light tower, right? It already knows what sequence it has to follow.
correct. Looks like we've just aborted our
Man,
run.
you know that totem exercise, man. It's like killing all the.
Yeah, it looks like it. I'm not sure why we aborted this time, but
No. Let's see. Okay, so just hypothetically, if it's like maybe kind of a challenge, can you resequence the exercises that you attempt?
yes.
So instead of going to the totem, you maybe do a docking and maybe do the ring retrieve.
Yes, based off of how much time we have remaining and how confident we are in our ability to complete tasks, the software team can use that tool I mentioned earlier to change
Right.
what tasks we do and in what order.
Right. Okay. So right now, if it's in manual, it's got to come back. It's going to have to restart everything. So at a minimum, I mean, you've already done the scan the code and the obstacle, but you're going to have to redo that again, right?
Yes. With this competition, they take during your time period, they take your best run as the run that you get points for. In 2016, it was a little different. It was the run you ended on. So we had to do a lot of strategizing on, okay, how was that run? How does it compare to what our goal is? Is it worth attempting to retry? Because if we don't achieve the same score as we did last time, then that's it. We get the new score.
Right. I mean, like in the previous team, the Singapore team, they actually were able to go pretty far in one of their runs, and then they came back and they attempted, to redo the course, but they were never able to get as far as they got, in that one run. So I think that's probably going to be the one they measure.
Yes.
So what? You got a message here?
Yeah, I received some intelligence from my team that we are going to attempt the underwater ring challenge. We're the only team at this competition so far who has deployed and retrieved our AUV as well as retrieving a ring from the course.
Right. Because the Singapore team, I asked them about that, and they were actually looking at just launching and retrieving, but they did not get a ring.
Correct. It is worth noting that our AUV is attached to our vehicle, as opposed to a separate sub that we deploy. We have a what kind of looks like a tree. It's like a long stick with hooks on it, and it approaches the challenge, lowers we call it the Grinch because we think of the underwater ring challenge as kind of like a Christmas tree, and the Grinch goes and steals ornaments, and our intention is to steal rings.
Okay, so now it's in autonomous mode. It's gone through the entry, right? It's got to still. Does it have? It has to do the scan the code, right? Or no?
I'm sorry?
Does it have to do the scan the code?
We don't have to do scan the code.
Okay. So now it's just going it entered. Now it's going to go do which exercise? The ring retrieval?
It should be going to do the ring retrieval,
Okay.
yes. So the ring retrieval is underneath, it's underwater, so you can't see
Right,
it, but
right.
it's,
So
it's
that's the
beneath the
orange buoy,
two-tone
right?
buoy.
Yeah.
Which we like, that is orange and blue because those are our school colors.
Oh, okay.
So what we call the Grinch will lower down, and then we'll start to spin, and it will spin. So and as it rotates around the buoy while facing the buoy, and with the intent that we pull rings off of the underwater ring challenge, and hopefully collect them to the surface.
Now, how far away from the buoy does the vessel need to be in order to be in the right distance for the Grinch to do its job?
For the Grinch to do its job, the Grinch is located on the front bar of the vehicle, and its hooks extend approximately 12 to 30 inches or so. So it has to get pretty close. The buoy has to be right up in between the front pontoons of the vehicle.
Okay, so now what we're seeing is that the buoy is in between the two pontoons.
Correct.
So it's in the position, right? And now
Yes.
it's sort of starting that spin that you just described.
Yeah, so the Grinch has been lowered. If you notice the vehicle backed up,
Right,
that's because the way we lower our Grinch is with a winch. We just release it and let it fall down. So to make sure it fell down all the way, we back up to kind of swing it up, or swing it forward, and then we drove forward, and then.
So you were actually, when you backed up, you actually deployed the Grinch.
Yes. It looks like our run has ended while we were partially through rotating around the underwater ring challenge, and we hope we collected some rings, or at least knocked some rings off. At the very least, we attempted the challenge.
Yeah, no, that's great. So what is going to be determinant of your score would be whether this run, which attempted the ring, is better than the run that you did previously, which was the scan the code and go through the obstacle course.
Correct. That will determine our final score.
Okay.
But we're really happy we tried the ring challenge because no other team has done so, or we believe will do so, and we want to do that to show that we could.
Great. So
I'm
impressed. I mean, I'm really, I'm counting on you. I'm watching you guys. You guys won last year.
We did.
You guys, I want to see if you guys going to reprise that championship.
Yes, I graduated this week, so I'd really like to end school on a high note, my university career on a high note.
So tell me, in what role are you going to play moving forward with this?
Yeah. So our alumni have a history of continuing to be in communication with our team, definitely socially, and often with advice on selecting parts because and algorithms and how to design things because they're now in an industry where they can learn from people a lot more experienced, and they pass that back. So I hope to when I move on in industry, hope to continue to be able to support Mill and give them advice.
Now, in terms of the teams, the way they participate in the actual development of the vehicle, and then the alumni that have already been a part of it and graduated. I mean, how hands-on would the alumni be? Pretty much hands-off? Or?
No, I mean they've scattered to all corners of the nation, so it's more of like asking advice.
Advice,
and then occasionally they'll help us with design reviews. So they'll say, well, we designed this thing. We're not too sure if it's going to work. Can you take a look at like our circuit board or CAD design or something like that?
Now, is there a faculty member or somebody in one of the labs that sort of is the connection or continuity through the years?
Yeah, so I completely forgot to mention him, but Dr. Eric Schwartz is our faculty leader of the lab, and he's been in Mill since he started at UF, which was, I don't know, in the 80s or something.
Oh, okay.
And
he probably started it 30 years ago, right?
Yes, he did his bachelor's, master's, graduate degrees at UF while in Mill, and then he became the leader of Mill. And he runs the lab to be a place where undergrad students can come, or undergrad and grad students can come and build robots and have fun and compete.
Wow, no, that's great. That's
and
great.
he gets us the money we need to do so, and helps us come out to Hawaii. And he's all about us learning a lot more than we learn in school by working on things like this and really setting ourselves up for success later.
Yeah, no, that's impressive. That's impressive.
I just got word that we got 2 rings.
Oh, 2 rings.
And we showed that we recovered them. Not sure how this is going to work out point-wise. It would be great if we did it during our big run. But the fact that we've done so and another team has done so is really incredible.
No, that's great. That's great. Now, was the ring retrieval part of 2016?
It was not. In 2016, they had an underwater vision challenge.
Okay.
Unfortunately, the water was too cloudy in 2016 to see very far at all, so no one was able to do it. In addition, the obstacle course wasn't really attempted in 2016 either, but it was adjusted for this year, and a lot of teams have been doing it. So the underwater ring challenge is new. They want this competition to be all about systems of robots interacting together. So by encouraging the underwater ring challenge, they encourage teams to build submarines that work with their service vehicle. Of course, we worked a little bit around that by not using a submarine, by using the Grinch, the ROV, but we're still very happy that we're able to both work above water and underwater.
No, that's great. So that's I think a recognition that you folks can go down in history. You got the first ones to accomplish the ring retrieval.
Yes. And
now I would have wanted to see the detect and deliver.
Yes. And I would love to see totems. That's a challenge.
Now, when you did the qualifying rounds, you did the detect and deliver, right?
We did not.
Oh, you did.
But we did do totems. We did. We were one of two teams that completed 6 qualifying challenges. We did the underwater ring challenge, obstacle course, scan the code, the dock, and the entrance and exit gates.
Okay, great.
Yeah.
Well, I do want to thank you, Matt, for joining me and giving me the rundown on all the inner workings of the University of Florida, and I really wish you a lot of success. Now, which
Thank
one?
you.
Now, let me ask you, just candidly between you and me. I mean, which run would have gained more points? Do you think? I mean,
I believe the run where we ended on the totems probably would have gained more points, but the run we're happiest about and most proud of is the ring retrieval round. Yes.
All right. Congratulations.
All right. Thank you much.
Thanks a lot.
Have a great day.